Right, so up until now, we've learned about linear number patterns, all right? And what we know about a linear number pattern is that it's defined by the fact that it's got a first common difference, all right? What does that mean? If you've got the jump from your first term to your second term, which is the same as the jump from the second term to the third term, and so on, that is giving you your first common difference, okay? And what is the general formula that represented your linear number pattern? Term n was equal to an plus b is the standard form of a linear number pattern. And if you recall, how do we find the actual equation that represents a number pattern? Well, using this as an example over here, let's see. The first thing, obviously, let's do is work out, is it actually linear? And the way I would do that is by saying term 2 minus term 1, which is giving me a difference of 5, and term 3 minus term 2, which again is giving me a difference of 5. So can you see how that difference is remaining common and therefore telling us that it's a linear number pattern? Now, in order to find the actual general term, the Tn formula that represents that number pattern, the first thing you need to know is that, oh, no, we don't want to do that. The A actually represents that common difference, okay? So once you've established in this case that the common difference was 5, well, that A is now going to be able to be replaced with 5, okay? Now we have to find the B value, all right? And the B value is actually quite simple to solve for. All you need to do is solve it by good old substitution, all right? If this is term 1, all right, what I'm going to be able to say is this. If term 1 is equal to 9, then instead of n, I'm going to replace my n with 1. And by doing that, we can make the whole equation equal to 9, all right? Similarly, if this is term 2, then I can replace n with 2 and I'd be able to make the whole expression equal to 14. So it doesn't matter which term you choose, as long as you're making, if you're putting n with 3 or whatever it is, then you're making it equal to the third term, all right? So that's obviously the important part. So I think to keep things simple, let's use n equals 1, and I'm going to replace term n, the actual value of your first term is 9. So therefore 9 is equal to 5 multiplied by 1 plus b, all right? And that means that 9 minus 5 equals b, and 9 minus 5 is 4, and that is your unknown b value. All right. So therefore, what is the Tn formula? The nth term of this linear pattern is 5n plus 4, and once you obviously have that formula, you can find whatever term you like. If I wanted to know, for instance, the 58th term of this sequence over here, all we'd have to do is substitute 58 into your n, and you would be able to solve for your 58th term. Okay, so once you've got your general term, you can find anything you like regarding the pattern. So now we're going to move on to quadratic number patterns, all right? So we know that a standard quadratic equation is given by the standard form Tn is equal to an squared plus bn plus c. Remember, quadratic means that your n or your x variable has the highest exponent of 2, all right? So whenever it's an n squared equation, you've got a quadratic equation, and this is the standard form of it, okay? So we're going to just play around a little bit with this and just establish a bit of theory behind it first before we actually do an example. If this is my standard equation, all right, if I took n equals 1, which represents the first term of your sequence, all right, and I substituted 1 into the unknown n variables of my standard equation, all right, we're going to land up with a expression of a plus b plus c, and that's going to represent sort of the general term of your first term of a quadratic sequence, okay? If I took n equals 2 and I substituted, it's the same process, if I substituted 2 into those n terms, all right, we would land up with a general term of 4a plus 2b plus c, which represents the second term of your sequence. If I continue to do the same thing, if I substituted 3, we'd land up with 9a plus 3b plus c, representing your third term. And finally, 16, well, not finally, this could carry on, but in this case, we're going to stop at 4. 16a plus 4b plus c will represent the fourth term in your sequence. Okay. Now, what we're going to illustrate here is we're going to start by finding the first difference between the terms. And let's see what happens when we find that first difference. To calculate a first difference, you always take term 2 minus term 1. and then take term 3 minus term 2, and so on, all right? So term 2 minus term 1, all right, if we work that out, is going to simplify to 3a plus b, all right? If I took term 3 minus term 2, that's going to simplify to 5a plus b, and term 4 minus term 3 is going to simplify to 7a plus b. Can you see that those differences are not the same? So it is not linear, all right? So we have a difference, a first difference, but they are not common first differences. So therefore, we're going to go another layer down, and we're going to see if we can find a second difference and see what happens with those. So again, term 2 minus term 1, that's giving me a difference of 2a. Term 3 minus term 2 is also giving me a difference of 2a. So can you see how with that quadratic number pattern, you are landing up with a common second difference by working out your first difference first and then doing another layer down and finding your second common difference. Okay, so a linear number sequence is defined by having a first common difference. A quadratic is defined by having a second common difference. All right. Okay, so let's take an example and let's see if we can actually find out how do we actually work out the general Tn equation of a quadratic equation. All right, so we've got 7, 15, 27, 43, all right, and we're being asked to determine the nth term of this sequence. Well, to start, you have to start by taking, remember this represents term 1, this represents term 2, term 3, term 4, okay? So we start by saying term 2 minus term 1, 15 take away 7, that's leaving us with a difference of 8. Term 3 minus term 2, that's leaving us with a difference of 12. And term 4 minus term 3, that is leaving us with a difference of 16. Okay, so it's not a common difference. So we need to go another layer down. Term 2 minus term 1 is giving me a difference of 4. And term 3 minus term 2 is also giving you a difference of 4. So therefore, we know that, that if we've got a quadratic sequence because of your second common difference. Okay, so we now know it's quadratic. Great. How are we going to find the general term? Remember, your general term has the standard equation. Term n is equal to a n squared plus bn plus c. So we've got to find an equation in this format that's going to represent this number pattern. Okay, where do we start? Well, we've got a nice little method we can use over here. Have a look over here. Do you agree that this value of term 2 of 2a down there represents the second common difference? All right. So if your second common difference is 4, then what I'm going to say is, well, if 2a represented my second common difference, then I'm going to say 2a equals 4. All right, and I'm going to be able to solve for a by dividing by 2, and then in this case a lands up equaling 2. And now we need to solve for the unknown b and the unknown c value. So we go back to this over here and we say, okay, this 3a plus b represents the first number in that first row of common differences, okay? So we're going to look at the first number in this row over here, which was 8, all right? And we're going to say, well, if that was given by the general term of 3a plus b, then I'm going to be able to say 3a plus b is equal to this first number over here, which is 8. All right. Now, don't forget we've already solved for a. We already know a is 2, so therefore we're going to be able to say 3 times by 2 plus b equals 8. All right, which means that b is equal to 8 minus 6, which is also 2. All right. Now we need to solve for c. So we go back to this over here and we say, all right, this a plus b plus c represented the first term in your sequence. Well, the first term in my sequence over here was 7. So I'm going to say a plus b plus c is equal to 7. So therefore we've got a plus b plus c, and that is equal to 7. Now the a, remember, we knew was 2. The b was 2, and the c is unknown, and we are trying to solve for 7. So therefore c is going to equal 7 take away 4, and that's going to leave you with a difference of 3. So therefore, what is my Tn formula? Term n is equal to a, which is 2n squared, plus b, which is 2n, plus 3, which was your c value. Okay, so it's a nice handy method to learn. The only thing I would say to you is that obviously when you're doing this, you need to learn this, okay, that in order to use this method, you always put 2a equals, and you actually make an equation out of that bottom row, all right? In front of here, we say 3a plus b equals, and we make an equation out of that middle row, and then we say a plus b plus c equals, and you actually make an equation out of that top row. So you do need to learn that, all right? Make sure that you learn it. However, if you forgot it in a test, if you couldn't remember what they were, you can go back to the process of substituting like we did here, where we substituted 1, 2, 3, and 4 into the standard TN formula, and you could actually get back, you could create this little diagram for yourself, but that's time consuming and you don't want to waste time like that. So learn the method, okay? If you learn it, it makes life a lot easier and you're able to solve your quadratic equation really easily, and it's a really nice way to get there. So practice that. I've got a couple of examples that I'd like to do with you following this. So please join me there and we'll work through those together. Well done.